All right. I like lightning talks because there's no fluff, is there? I have no slides. We're going to look at code. My name is Sid. I work at Cloudflare in this building. I've been here for about 2 years. I worked on workers, pages, a bunch of stuff at Cloudflare. Lately, I've been building something new. That's what I'm going to show you. I don't think I've shown this publicly yet. There's been a blog post announcement. This might be the first one. So let's get right into it. It's super alpha. It might not work. Fingers crossed, I guess. Anyway, how many of you have used ingest or temporal or Apache Airflow back in the day? One person in the room. 4 people in the room. Holy crap. Okay. Let's start from the top then. All right. All the way from the back. When you have long-running tasks that you need to do, typically they are hard. They're hard because, when we all do a fetch call in node.js or on the web, we expect it to just work. That doesn't happen, right? Network fails, I/O fails, all sorts of things fail, connections break, DNS doesn't get resolved, a connection, packets get lost, etc., etc. Reliability over distributed systems is a hard problem. Right, more often than not, if you're writing services, if you're writing a lot of little services that do a lot of work together, you've probably built in retries yourself. I'm sure all of you have done that at some point, right? You've probably used queues to be able to queue or batch jobs that need to happen out of band of the request. So far at Cloudflare, right, we've had the only compute sort of the only compute product, so to speak, that we've had has been workers. How many of you have used workers? Okay, that's great. So a lot of you are familiar with workers and how we run JavaScript on the edge. It's just V8 isolates, really. In fact, we even have Node.js compat now. We're sort of working towards it, right? But as you all know, most likely, workers are meant for short-lived requests. They don't last very long, They can. I mean, if you're on an enterprise plan or whatever, you get unlimited wall time and about maybe 10 or 20 seconds of CPU time. But 10 or 20 seconds of CPU time is not a long time. If you want to run any kind of sort of background task like transforming videos or generating a bunch of images, or lately AI is all the hype, if you want to generate embeddings for a RAG. How many of you know what a RAG is? Oh, wow. People love AI, don't they? All right. So RAGs, typically, for the ones who don't know, are a way to take an AI model and give it context about your own data, right? You have your own internal wiki pages or your PDFs. You sort of give the AI context about it, so you can now chat with the AI about stuff that only you know in those documents that isn't sort of publicly available. RAGs are really painful to build as well, because most AI systems today, because of how young they are flaky, right? We're going to build a RAG today. In fact, I've already built it. We'll pretend like we're going to build a RAG today. And I'm going to write a quick sort of demo for you today live as well. The product that I'm going to show you is, we're calling it workflows. I've been building workflows for about, I want to say about 10 weeks, give or take now. It hasn't been very long, very early days. But let's just jump straight into what a workflow is, all right? So I have this workflow demo here. A lot of these types will change because obviously we're just sort of building. Is that visible? How is that too small, too large? How are you feeling about that? Yeah? Too large? All right, okay, sure. If you say so. All right, so what this is doing, now pretend that a lot of types are different because, like early products, things change. But the core idea here is that you write a class, right? Just like you write a class in JavaScript. We're not reinventing a programming language here. But you extend something called, today it's called worker entry point. Tomorrow it'll likely be called workflow, once you've sort of figured that out. And you write a function called async workflow in there. Within that function, what you can do is you can separate your code into a bunch of closures. Now, each of these closures, as you can see, are being passed into something called a step.run function, right? This might look familiar if you've played with a lot of these tools lately, like ingest and so on. And I think the goal here is that it ought to look familiar. We don't want to reinvent wheels. But what do they do for the ones who haven't played with them? Step.run will atomically run all your code in that step. If anything fails, it'll roll back. We're tracking all I/O, all sub-requests, all compute that runs within that closure. We're able to roll it back if there's an error thrown within there. All right, so think about step.run as a database transaction, but for your code. It'll automatically retry. There's same defaults here, but if you want to override them, you can pass in an object with retries set to a limit of 10, with a delay set to, I'm sorry, not a delat, a delay set to 1 minute, and back off set to, you can do constant, linear, or even exponential. In fact, I believe this is the default, if I remember correctly. But you can override them. Now, the idea here is that you don't have to think about these things. Retries happen automatically. If you have a bunch of events coming in, and based on your batching settings for your workflow, you can automatically batch them in the sense that the workflow will run once for every 10 or 15 events as opposed to once for each, right? You can even do something, well, called sleep. Now, this isn't a micro task. This isn't a set timeout under the hood, right? You'd expect this to solve. I mean, everyone's written a sleep function. The way you typically write a sleep function is that you wrap a promise and you set a set timeout and you pass a closure that calls resolve eventually, right? That's how you typically write a sleep function. This isn't that. This is pausing all execution for you, right? So you don't get billed for the time that the sleep is going on, which is why it doesn't just have to be 5,000 milliseconds. You could sleep for a year. And that works, shockingly, right? You could sleep for a year, you could sleep for 30 days. The typical use case for something like that is, subscriptions. You can subscribe and charge a card every 30 days. And you can co-locate all of that code by literally saying charge card, sleep, trigger again, right? All of this without having to think about things like queues or event primitives under the hood. In fact, one more thing before I actually run this demo that I'll show you, is that you can even do this. You can even say that you want to wait for an event specifically. So imagine if you had, and I believe this takes a type and a name and a bunch of other crap. I actually haven't built this yet. But imagine if you have an R2 bucket where something gets, constantly, uploaded. Or if you have a dashboard where some chap has to literally click a button, that's okay, but you can just wait arbitrarily for some other side effect to occur and pause execution till there. These are really interesting primitives, and they sort of flip how we think about writing, business logic. You're no longer thinking in queues and database rows and like low-level primitives, but you're sort of thinking in steps and events and so on, right? Let's try running this and see if it actually works. The way to deploy these is actually quite simple. You can call Wrangler workflows deploy. This is not publicly available yet. There isn't even a closed beta. There's nothing. It's just on my machine. Actually, that's a lie. It's very much on the edge. But there will be a closed beta shortly, in a few weeks, not months. I've already deployed this. So I won't bother you with that time because we're running short of time. But I will trigger an instance for you. And what triggering an instance looks, and please don't steal my bearer token. It's somewhere in here. Oh, it's in a different tab. Okay, cool. That's fine. Don't pay attention to any of the UUIDs. But the way you trigger a workflow is it's similar to a worker where you create requests. You trigger instances of a workflow. We're going to trigger a new instance today, right now. So if you list instances for this chap called LNUG demo, which I just deployed right now, you'll see that the status is complete. It was created roughly about maybe 4 or 5 minutes ago. This is UTC time, which is why it's an hour prior. I'm going to create a new instance of it. Now, by the way, what this workflow does is very trivial. It calls this thing called webhook.site, which is a very cheap way to get someone to show me that an API call happened, right? It looks like this. It basically tells me that, oh, look, an API call happened. So what I'm going to do is I'm going to get rid of all the other API calls and trigger a new instance. You should see one call. Nothing super impressive here. That's all good. But let's take a look at how retries happen. if I go back, move all of this a little back, make it real code, and get rid of all of this, and say that I want to randomly, how much time do I have, by the way? 4 minutes? That's plenty. All right. So if I want to say that if I have a maths.random, and in the world of probabilities, if we have the worst luck ever in this room, if an error gets thrown, we'll throw an error. Okay? Now, what should happen in theory is that this should just fail. But because retries work under the hood, like I said previously, it should just work. So let's see if that happens. All right? We're going to go ahead, and this all looks good. Right now, there's a small bug where I need to actually always say that there's a fetch function as well. Pretend like I'm not writing this right now. Okay? Yeah, that didn't happen. But anyway, we'll deploy a new version of this workflow. So I'm going to call npm run workflow, npm run deploy, I'm sorry, because I have a custom version of Wrangler in my package JSON. And it's uploading a script and setting up some metadata and so on. All right, that's done. Now, in theory, that should just fail. Let's see what actually happens. I'm going to create a new instance again, okay? And you see that an API call happened. In fact, a second API call happened. And the reason a second API call happened is presumably because this math.random, through. Of course, the API call was before it. I should have probably put it after to make the point here. But you see how this gets run automatically if something fails. My next demo in a few weeks, I'm actually building it right now, will be about replaying events, and we'll be able to show you the transactionality and atomicity elements, wherein if something now throws within a queue, you would go back and sort of roll back the previous IO things that you've done, which is really interesting. Now imagine being able to have something like a const map in here. And when I say IO, by the way, I mean both IO and compute. But imagine having a const map in here, and imagine doing a map.set to blah is 1, right? You could have it automatically roll back if an error got thrown later. So it's quite literally transactional JavaScript in a sense, right? This is something that most other platforms don't actually do for you today. Of course, there's other fun stuff about this, wherein if you had multiple steps, like you might wonder why multiple steps in the first place, right? If you had multiple steps and if one of them failed, you'll be able to upgrade your code by pushing a bug fix, but resuming from the last step that succeeded. Now, that sort of stuff is really valuable when it comes to really expensive compute, as you'd imagine. Finally, I probably have a minute, so I'm going to show you what a RAG would look like. It's quite simple, really. We have access to every binding you could use on workers, on workflows as well. You'd have an event come in. Oh, by the way, events can trigger workflows. That's also upcoming. It's part of this. You'll have events that are both platform-wide as well as user-defined. You'll be able to have your own user events on your Cloudflare stack and have both queues, workers, workflows, readable objects, all of them consume them any way you'd like, right? But in this case, there is an event coming in which is an upload to an R2 bucket. You can probably see that it says put object into my bucket, because basically I deploy something and it runs, right? And it runs a workflow, gets the keys, reads the objects from R2, calls some model that I don't even understand. Someone told me to use this model. I don't know if it does anything. It generates embeddings. In this case, it retries exponentially because we know that the AI is flaky and it might, you don't want to put in too much, pressure onto it. And finally, inserts the vectors into this vectorized database that we have, which is a vector database. Now, I already have all of this set up, so I'm going to end this demo by, of course, logging into the dashboard because I didn't do that before. And I'm going to upload a file to R2 for you, and you'll see that the RAG gets run. Now, unfortunately, the cheapest way to show you that the RAG actually ran is to just show you the API response. I mean, I don't really have a consumer of the vectorized instance just yet. But hopefully that should be fun. So let's open R2. I have this documents bucket in here. I'm going to go ahead and upload. I've been uploading absolute random shit in here, so I'll go ahead and upload I don't know, like a bill. I don't even know what bill this is. What the hell is that? It's some bill. Is it a pay slip? Can you see it? I can't. It's something that I either paid for or that I need to pay for. Oh well, anyway. So we're gonna upload that. Now that's all I've done. I've only uploaded a file to R2, but because of the R2 notification being sent over and the workflow being instantly created, we will be able to list our instances. That workflow is called, I believe it's just called RAG, but honestly, let's find out. We can list our workflows. RAG workflow, there you go. So I'm gonna go to RAG workflow and list our instances. And it says error. Interesting. So it didn't like the PDF or whatever I sent it, presumably. But hey, you know what? Sometimes shit fails. It'll work the next time. I'll leave you at that. And yeah, eventually when this is in closed beta, please feel free to play with it. We do believe that this could be a very new and interesting compute model for us on Cloudflare, and we'd love to see what people build with it.
That's awesome. Love a lightning talk. Thanks for showing us the work in progress and in preview. And sorry the demo gods didn't entirely